So in the sludge treatment, we have seen in the previous videos that the sludge is composed of two main things. One is solids and second is water. So the water we are calling it as moisture content of sludge, and these solids are classified into volatile solids and non-volatile solids. Then what is the aim of sludge treatment? So our aim is to reduce the volume and to reduce the strength of sludge. So this is achieved by the following four processes. Initially we are doing the sludge thickening and sludge digestion. Then to reduce further the strength of the sewage sludge, we are doing the sludge conditioning. After the sludge conditioning, the final stage is to dewater and to dry the sludge and then go for the disposal. So the first sludge thickening we have seen. In today's video we will be seeing the sludge digestion. In short, what is the sludge digestion? In sludge digestion we are doing the anaerobic decomposition for strength reduction. So let's see this sludge digester. So give the heading sludge digestion process or sludge digestion. So when the sludge is digested, the volume of original sludge, it is reduced to 1 by third of the original value. Okay, so volume of digested sludge. Digested sludge. How this is digested? By doing the anaerobic decomposition. Anaerobic decomposition. What is the meaning of anaerobic decomposition? It means in absence of oxygen. So the volume of digested sludge, it is approximately 1 by third of the original volume of sludge. Original volume of sludge. The sludge gets broken, that is the original sludge gets broken into, so it gets broken into digested sludge, digested sludge. The second one is called as supernatant liquor, supernatant liquor or liquor, and the last is gases. So certain gases are formed due to this anaerobic decomposition, and these are the gases. So the sludge is, or we can say, instead of writing sludge here, we'll write fresh sludge. So the fresh sludge gets broken into digested sludge, supernatant liquor, and gases. This supernatant liquor, it is very dangerous and it is having BOD of around 1500 to 1600 mg per liter. Okay, so we cannot directly dispose this, and hence to reduce the BOD, it is again retreated with raw sewage. So write down this point. To reduce BOD, it is retreated. It is retreated with raw sewage. What is the meaning of raw sewage? The first initial sewage which is coming to the sewage treatment plant, in that this supernatant liquor is added, and then again it goes to the all same processes. Okay, so these are the various things in which this sludge gets broken. So some other points are, so the total solids, so we have seen that sludge is divided into solids and water. So this total solids consist of volatile and non-volatile. So this volatile component is 70% and non-volatile component is 30%. So this total solids in this volatile is 70% and non-volatile is 30%. So that will give us a total 100%. So these are the extra points that if you want you can remember. So these volatile solids are measured by, so we can measure it by an equipment which is called as muffle furnace. So there is a process in which we can find out the amount of volatile solids. So you just remember this name. We can measure it by using muffle furnace. Okay. So now this is the basic introduction about sludge digestion. Now what are the stages? We have to see that in detail in sludge digestion process. So the next heading will be stages in sludge digestion process. This is very important topic. Directly from this there are questions. Okay, so what are the stages? So the first stage is called as hydrolysis stage. So hydrolysis stage. Then the second stage is fermentation, or this is called as acidogenesis stage. Acidogenesis stage. And the last one or the final stage is methane formation. Methane formation. And this is called as methanogenesis. Methanogenesis stage. Okay. So these are the three stages. Very important. Directly this is asked. Like which of the following is not the stages in sludge digestion process? So these three will be given and one more option will be given. So based on that you should be able to answer it. Okay, so these are the three stages, and which is the first stage? Hydrolysis. Then second, fermentation, that is acidogenesis, and the third one is methane formation, methanogenesis. So in hydrolysis, write down, this is the first step. So this is the first step, and in this particulate matter, particulate, or we can say particulate material is converted, it is converted soluble compounds into soluble compounds. So organic matter complex organic matter is converted into complex organic matter is converted into simple and stable organic matter. Okay, so this is the first stage. Now once the complex organic matter is converted into simple organic matter, then the next stage is the acidogenesis, or it is called as acid fermentation stage. So in this stage what happens is that the sludge is reacts, or we can say sludge reacts with the acid formers bacteria. Okay, so these acid formers, what they do, they produce the acids. So that means the sludge, if we write it, it is very easy. Okay, so this acidogenesis means acid will be formed. So whatever the sludge is there, so this sludge is reacting with acid formers, and on reaction with this there is a formation of acids. So which acids are formed? So just remember this name: acetic acid and butyric acid. So there are various acids are formed, but these two are major one. Okay, now once the acids are formed, once these acids are formed, in the next stage these acids are converted into gases, and the major gas that is produced is methane. Hence this is called as methanogenesis process or methane formation process. Okay, so I will just highlight it here. See, these acids are formed in the second process. These acids are then taken to the next stage. So here the acids will be reacting with methane formers. with methane formers, and they will give us the gases. So gases will be produced. Now what are the various gases that can get produced? So we know that the major is methane, then carbon dioxide and hydrogen sulfide. So these gases we have already, this reaction we have already seen in the anaerobic and aerobic reaction video. Okay, so in the previous video you can see. Now these gases are finally produced by the reaction of acids with methane formers, and as the major gas is CH4 methane, hence it is called as methane formation or methanogenesis. So this methane is 60 to 70% of the gas, and carbon dioxide is 20 to 30%, and remaining are other gases. So write down a note here. Methane has a high calorific value. Hence it is used as fuel. Hence it is used as fuel. So the heat content of methane is around 8600 kilocalorie per meter cube. So these are the all stages in the sludge digestion process. These all the processes, this occurs in an equipment which we call it as sludge digester. Okay, so in this sludge digester, hydrolysis, fermentation and methane formation occurs. So we'll write about this sludge digester in short. So this sludge digester is an airtight, watertight anaerobic reactor. So it is an airtight, watertight, anaerobic. Very very important. Okay, so it is anaerobic reactor. So in this sludge thickening, sludge thickening and sludge digestion occurs. Sludge thickening and sludge digestion occurs in the sludge digester. So quickly we'll draw a small diagram of sludge digester. So this is the ground level. So there is an outlet here at the top. So this outlet is for gases. The sludge enters from here, fresh sludge. So the fresh sludge, it is present in this topmost portion. So below the sludge, or we can say below the fresh sludge, there is the digested sludge. So here there is digested sludge, this is fresh sludge. From this fresh sludge we are getting two outputs that we have seen. The fresh sludge is broken into digested sludge, supernatant liquor and gases. So this fresh sludge which is coming inside, it is getting digested. So this is the one part. The second part is in terms of gases. So there will be certain gases here that will be taking place during the anaerobic decomposition, and the output will be supernatant liquor. Okay, so this is how the fresh sludge is broken down into digested sludge, supernatant liquor and gases. So here there is a drain. From this drain also the supernatant liquor is produced. Okay, so as you can see in this portion there is a digestion of sludge, that is anaerobic reactor. So here in this part there is anaerobic reaction. Anaerobic reaction. Now what are the formulas related to this? So the first formula for the sludge digester is the capacity of sludge digester. Capacity of sludge digester, that is nothing but the volume. Okay, so let's write it down. Volume we want to find out. So there are two methods to find out this volume of, or we can say capacity of sludge digester. So I'll write both this and then we will see which formula to use in which case. So there are two formulas for this. The first formula is volume is equal to Vf minus 2 by 3 into Vf minus Vd into T. Second one is V is equal to Vf plus Vd divided by 2 into T. So when to use which formula? So if the volume of tank, it is calculated with an assumption that volume changes takes place parabolically. So let's write it down. If volume changes occurs parabolically, then you have to use this. If we are assuming that the volume change in sludge digester occurs linearly, then we will using the second formula. Okay, so now in the question you have to read which assumption is taken. See, if there is no assumption which is taken, then I prefer you should go with the first formula, because it will give us, or we can say in practically there will not be any linear volume change, there will be a second degree, that is parabolic volume change. Hence this will give us a more accurate answer. So if in question nothing is given, go for the first formula. If it is given that the volume changes are occurring linearly, then you should go with the second formula. Now, so this is the first one. Now what is this Vf and what is Vd? So V we know, this is V. This Vf is volume of a fresh sludge. Volume of fresh sludge per day. Then second is Vd. So this is volume of digested sludge per day, and T is called as digestion period. Or this is also called as detention period. So generally this detention period we are taking it as 30 days. So in sludge digester, many times it is 30 days only. If in question it is not given, take 30. If it is given, then you take that value. Okay. So how to calculate this volume of fresh sludge and volume of digested sludge? So we have to use the same formula which we have derived in the previous video. That is, volume is equal to 100 by 100 minus moisture content P into mass of sludge, in this case mass of fresh sludge, divided by density of fresh sludge. So by using this formula you can find out the volume of fresh sludge, similarly volume of digested sludge, and then substitute these formulas in this equation to get the capacity of sludge digester. I hope this is clear. Now the last point in this sludge digestion is, what are the factors affecting the sludge digestion? So there are many factors which will affect the sludge digestion. So but we will see the two most important one, that is factors affecting sludge digestion. So there are two main factors. The first one is temperature and the second one is pH. So how does temperature affects the sludge digestion? So there is two ranges here. So we'll write this range first. So first one is a mesophilic range. So in mesophilic range, and this range is between 20 degrees to 40 degrees. In mesophilic range, mesophilic bacteria acts. Mesophilic bacteria acts. And the most efficient temperature in this range is, so in this range the most efficient temperature is 29 degree Celsius. This is very important point, so you should remember this. It is in mesophilic range. Then the above range, above this mesophilic, is thermophilic. So in thermophilic range, that is 40 degrees to 60 degrees Celsius, thermophilic bacteria acts. Okay, so in this thermophilic bacteria acts, and the most efficient temperature in this range is 54 degree Celsius. Okay, so if it is asked that what is the most efficient temperature during the sludge digestion, you should go with this 29 degrees. Okay, because the most, or we can say the best results are occurred when the sludge digestion occurs in mesophilic range and the temperature is 29 degrees Celsius. Now the second parameter is pH. So this pH affects the methane formation process. See, in this sludge digestion the third process is methane formation. So if the pH is lower, then there is less production of methane. So if pH is lower, less production of methane. So in methanogenesis. So how to increase it? So the remedy is to add hydrated lime. Okay, so these are all the important points which are asked in the previous year also. So that's why I have covered it here. No need to do PhD in this. Whatever the important points are there, that I have given it to you here. So with this, now our sludge digestion process is also completed. So this was the last stage in the sludge, or we can say sewage treatment. Now whatever the sludge is produced, that is the volume of digested sludge, it is taken to the sludge digestion bed after this sludge digester. Okay, so whatever the digested sludge is there, it is taken to the sludge drying beds, and this is the last unit. So what is this sludge drying beds? So these are the long beds on which whatever the digested sludge is there, it is placed for a certain amount of time. So it consists of two beds here. One is gravel bed, and above gravel bed there is a sand bed. Okay, this is a drain. Whatever the sludge is there, so that sludge, it is taken here on these sludge drying beds, and it is, or we can say whatever the remaining moisture content is there, it is getting evaporated. So write down first points in this so it will be more clear. So digested sludge digested sludge is dried on solar beds, or we can say open drying beds to remove remaining moisture content. Okay, so whatever the remaining moisture content is there, that is removed in this sludge drying beds. So how much time it is kept? It is kept for 3 to 4 weeks. 3 to 4 weeks solar dried. See, this solar dried means open to sky. Okay, so this moisture content, whatever it is there, it is getting evaporated, and this is our sludge. So this is how the entire sludge is taken and disposed.